There we go. Now I'm not going to lag as much. Okay, so we've got our equation. Let's pop over right here. So let's say S of n equals A sub 1 times 1 minus R to the n divided by 1 minus R. So let's say that we've got our sum as, I don't know, what K goes from 1, excuse me, 1 to 7 of 5 times 1/2 to the K. Okay, well, the first thing that you're going to want to do with this is apply your rules. Get your 5 out of there, because that's just going to mess with everything. I'm going to pull my 5 out, because remember, the sum of a constant times something, I can pull that 5 out, and I end up with the sum as K goes from 1 to 7 of 1/2 to the K. Now, I'm going to tell you guys this year and next year in calculus. If you're confused in terms of what you're looking at, just take a second. Go 5 times. Now, what's my first term going to be? When K is 1, I'm going to have 1/2, right? When K is 2, I'm going to have a 1/4. When K is 3, I'm going to have an 1/8, and that's going to go all the way out. So I go plus, dot, 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 plus. That means the pattern continues until I get 1 over 2 to the 7th. Well, what's 1 over 2 to the 7th? What is 1 over 2 to the 7th? What is that? 256? I don't know what that is. Thank goodness I don't have that one memorized. Let's see. I'm guessing it's 256. Somebody put a gun to my head and made me guess. I'd say it's 2. Oh, it's 128, 9. Yeah, that was dumb. All right, so 128. See, even I make mistakes from time to time. So this guy right here is equal to 1 over 128. Now, think about adding all that up. That'd be awful. That's terrible, right? So we have this formula that's fantastic. The only thing that we need to do is we need to identify what A sub 1 is. That's this guy, which is 1/2. And then I just got to identify n. All right, what's n? Well, n is, I let n go to 7, right? Remember, K goes to n. Just remember that. Oh, and I should probably figure out what my R is. What is my ratio? My ratio appears to be 1/2, because to get from one term to the next, et cetera, I'm just multiplying times 1/2. Times 1/2, et cetera. Okay, so watch. All I'm going to do is I'm going to deal with this sum, and I'm going to multiply the whole thing by 5. So this implies that 5 times the sum as K goes from 1 to 7 of 1/2 to the K, excuse me, is equal to 5 times 1/2 times 1 minus 1/2 to the 7th divided by 1 minus 1/2. Now, there's a whole bunch of 1/2s floating around. Let's make sure we identify them all. Well, this 5 is just hanging out, right? This 1/2 comes from A1. That's my very first term in my series. All right. This 1/2 is R. I'll do another one after I'm done, so you guys don't freak out. Is R, right? And then the 7 is N. This 1/2 is also R. So here we go. This is equal to 5 times. Now, what do you notice? Let's clean this up a little bit so we can see what's going on. This is going to be 1/2 times 1 minus 1 over 128, right? All over 1/2, because last I checked, 1/2 minus 1/2 is 1/2. Look at those guys. They cancel. So what I end up with is 5 times, well, 1 is just 128. 128 minus 1 over 128. And I end up with 5 times 127, 128. So the cool thing here is ignore the 5 for just a sec. I can add up the numbers 1/2, 1/4, 1/8, 1/16, 1/32, et cetera, all the way up to 1/128, right? Without having to find a common denominator, which would be kind of a pain in the butt. We could probably do it by hand if we had to. And I know that it's going to add up to 127/28. Now let's see if I can do this in my head. 5 1/20s is 600, and 5 7s is 35. So this is actually equal to 635, 128. Isn't that cool? Which is pretty close to 5, just a shade under 5. That's pretty awesome. Okay, now watch. Things can get a little crazy, so let's be careful. What if I throw this guy out? What if I were to throw the sum as K goes from 0? Ooh, how spooky. Let's go 0 time, or let's go from 0 to 5 of, let's go 4/3 to the n. Now, again, when in doubt, list your terms. That's the key thing here, because you don't, it's like, wait, Ridley started it at 0, or what if I started it at 8, right? I wouldn't go from 8 to 5, that'd be ridiculous. But what if I went from 8 to 15, right? So you got to be really careful here. Let's list a few terms. My first term is going to be a 1, isn't it? My next term is going to be 4/3. My next term, what's my R? How am I getting from one term to the next? Well, I'm just multiplying by 4/3. So this would be 16/9 plus 64/27, etc. Plus, plus 4/3 to the 5th, right? Good God, what is that? 81/3, 245, ew. So 2 to the 10th. So that's 1,024. 9, 81 times 3 is 243. 243s. That's just this guy that equals that. No, I shouldn't write that equal sign. All right. So I got to add all those up. Good God Almighty, what am I going to do with this 243? That's just terrible, right? Excuse me. But we don't have to. All I have to do is identify A1. It's my first term. 1. It's my radius, or excuse me, my ratio. It's 4/3. What's my n? Now be careful here. How many numbers am I adding up? Am I adding up 5? Ooh, Ridley, it says 5 right there. No, we started at 0. So n actually equals 6. All right? N is the number of terms that you're adding up. You got to be real careful with that. Okay? So S sub. Now really what we're doing is S sub 6. Even though I finish at 5, I started at 0. S sub 6 is equal to A1, which is 1, right? Times 1 minus 4/3, and this guy is going to be to the 6th, right? Divided by 1 minus 4/3. Okay? So what do we end up with here? Ooh, this could be awful, right? So it's going to be 1 minus 4/3 to the 6th. 4/3. I'm going to have to cheat and use my calculator on this one, guys. I'm not that good. 3/3 minus 4/3 is negative 1/3, right? You agree with that? So what this ends up being is what? I'm going to do a little puff of algebra here. Watch how I do this. 3 times 4/3 to the 6th minus 1, because that negative flips this guy, right? And then that's what I end up with. So we'll throw that guy in the calculator real quick, and we're going to get 3 paren. I'm going to need to do another paren. 4 divided by 3 in paren raised to the 6th. To the 6th, right? And then I got to kick over and minus 1 and paren. We'll see what we get here. Luck be a lady tonight. Look at that. Oh, I want to turn that into a frat. Well, let's leave it like that for now. This equals 13. It's approximately equal to 13.856. Let's see if I can turn this thing into a fraction. It's probably not going to let me, but we'll see. Enter. Oh, look at that. Bitchin'. So this is, well, bam. We know it's got to have a common denominator of 243, right? Because you're adding everything up. I know this guy's going to be 3, 6, 7, 2 43rds. Let me expand on that just a little bit. I know it has to have the same common denominator as my last term, because my last term has the ugliest common denominator, and everything else is going to be divisible by that, because these are all common ratios. So if this number is any different than this number, it certainly can't be, the denominators, this can't be bigger than this. It could be smaller theoretically if you get some cancellation in there. Okay? So I don't want to get you too confused with that, but that's a good one. Okay, now I'm going to get crazy with you here for just a sec. All right, and then I'm done. You don't have to listen to me anymore. Well, a little bit more, but not a lot. Let's look back at S sub n. Let's just have a quick little theoretical discussion. Remember, A1, 1 minus r to the n, all divided by 1 minus r, right? And this guy comes from the sum as k goes from 1 to n of a sub k times r to the k, right? That's where it comes from. This is our geometric. This is our form, right? Nothing to it. Okay, so now, you know what? Theoretically, I'm getting a little crazy. I'm flying a little loose with this. Here's what I'm going to do. I'm just going to call it A. So I don't get confused in terms of this guy, because you might see a little bit of confusion. Wait, what's going on here with the one? The ones are different. So really, theoretically what I should do is a times r to the k minus 1, right, which is what we've talked about in the past. I can do this guy. All right? But it gets so confusing. In calculus, you know what we write? We just do this. If we started at 1, we go a times r to the k minus 1. All right? So we'll get you used to that. That's what I'm going to do. Just understand that the whole thing comes from the geometric, okay? And that this guy equals a plus ar squared plus ar cubed plus dot, dot, dot. Okay? Now, I want you to think about something. Suppose that r lives between -1 and 1. If r lives between -1 and 1, what are we doing? Now, we can think about it numerically, right? I am multiplying each subsequent term by a number that is a fraction, right? Theoretically, it's just a fraction. So it may be switching signs. If r is negative, every other term is going to be negative. That's called an alternating series. But each one of these numbers is getting smaller and smaller and smaller. But more importantly, think about what happens to this guy as n gets huge. What would happen if I let n go to infinity? Well, if r lives between -1 and 1, and I raise a number between -1 and 1 to an infinite number, in other words, if I raise a fraction to infinity, what happens to r raised to the infinity? Well, doesn't this imply that r to the n goes to 0? Think about that. You take your common ratio, and your common ratio is a fraction between -1 and 1. As n goes to infinity, r to the n goes to 0 because this guy's a fraction that's less than 1. And I'm just taking a number less than 1 and multiplying itself over and over and over and over and over again. Guess what? We're heading for 0. So doesn't that imply that s sub n, as n goes to infinity, converges? Now here's a new word for some of you. Converges. That means it heads for. Not only does it head for it, but it gets there as we get to infinity. Now you may say, Ripley, we never get to infinity. You're right. But we can get so close to infinity that we can't really tell well, let's back up. As n gets really, really huge, this guy converges so closely to a number that we can't tell the difference between the number that it goes to and the number that it converges to. In other words, mathematically, they're the same, which means it converges to, since r to the n goes to 0, it converges to 1, try this again, a sub 1 over 1 minus r. So what that tells us is, if I do what's called an infinite series, and all an infinite series is a series, except instead of stopping at n, k goes from, say, 1 to infinity. And this is going to be a times r to the k minus 1. Now, if r, and the fancy way we write this right here is, we say if absolute r is less than 1. They are mathematically equivalent. Okay? If r lives between -1 and 1, which is absolute r is less than 1, then the sum, and we don't write s sub n as n goes to infinity, we just say s. S equals a over 1 minus r. Notice that I'm saying a is the same as a1 over here, just because when k is 1, this thing disappears and you're just left with your first term. So I could write this if I wanted to as a1 and a1 here. Okay? I know it gets kind of crazy. And I was not entirely clear when I was putzing around back here with my a sub n and all of that. So bear with me. I apologize for that.